So we talked about how to add and subtract matrices and how to multiply just a single number by it. That was called the scalar multiplication. This is multiplying two matrices by each other, so a matrix times a matrix. Um, I know you probably don't remember all these words you learned back in Algebra 1 or geometry, but associative, commutative, transitive, all that fun stuff. Commutative just means you can multiply, if it is commutative, it doesn't matter what order you multiply them in. So numbers, they are commutative with multiplication and addition. It doesn't matter if I say 7 times 5 or 5 times 7, the answer is the same. That's not true with matrices, and I'll try to talk a little bit about why that is later in the lesson. But you got to make sure you know that with matrices, and this will be very important in a lesson later in the week, that multiplying them together, a times b, is not going to give us the same result as b times a. And with adding and subtracting, we had to make sure the dimensions were identical. If it was a 2 by 2, you had to add it to a 2 by 2. If it was a 4 by 3, it had to be added to a 4 by 3. You don't have to be identical for it to work when you're multiplying. Instead, you have to make sure the number of columns in the first one is equal to the number of rows in the second one. And I'll show you on the next slide a pretty quick and easy way to figure out if it will work or not. But here's the official way the math people want you to know about it. So one of the reasons I taught you in the first lesson how to write the dimensions of a matrix is that makes it very easy to see whether it is possible to multiply them together or not. So those of you taking notes on this page, it's truly up to you if you want to take notes here or not. Really, I think if you just listen, you'll be fine. But the four combos I have up here, you can multiply the matrices with these dimensions, and I want to show you why using my very special pen. What you have to do is, if you write it, the dimensions, like this is a 2 by 3 and a 3 by 5, you just look at the two numbers that are touching each other. If they're the same, then it works. That's the wrong pen. Here's my magic pen. Here we go. Look at the numbers in between. If they're the same, it works. If they're the same, it works. Hey, these two are the same, so it works. So that's why all four of them work. So as long as you name them correctly, it's really quick and easy to see. Whereas the four down here, if you look at them, these are not the same. So that's why we cannot multiply these two together. These two are not the same. These two are not the same in the middle. These two are not the same. So that's all you have to do is label them as far as their dimensions and then look. Yeah. Yeah. We cannot, because it has to be the number of columns in the first one and the number of rows in the second one. By the way, you'll see. No, 2 is rows, 3 is columns. Yeah, R then C. Rows then columns. Yep. I think when you see the examples, you'll understand what I mean. But ask again if it doesn't make sense why we can't when they don't match up. Okay, so here's our first example. I am going to require you to know how to do 2 by 2s by hand. Anything bigger, anything else, you're going to use your calculator. I'll let you use it. I'm even okay with you checking your answer for this in your calculator. But as far as tomorrow's quiz, you will have to be able to show your work like I'm going to show you here. So I know you do know how to do this by hand. But you will not have to do anything bigger than 2 by 2s. So we do know this works because it's a 2 by 2 by a 2 by 2. Speed up, computer. Yeah, you learned this probably in Algebra 2. Yeah, so the way we want to approach it is we take the first row and the first column. and we do the first number, 7, times the first number, 4, plus the second number, negative 2, times the second number, negative 4. So that's how we'd get the first term in our matrix. So that's why we have to make sure these two numbers line up, because otherwise when you try to do this row by this column, it won't match up. You'd have different numbers. Like if you had 3 in this row and 2 in this column, they wouldn't line up when you try to multiply them. Okay, so now that we've done the first row in the first column, we move over and do the second column. But we repeat the same process. We do the first number times the first number plus the second number times the second number. So I did 7 times 9 plus negative 2 times 1. So now I've done everything I need to with the first row. So I move down and look at the second row, and I'll do the same thing with it in these two columns. So now I'm doing the second row times the first column. I do negative 1 times 4 plus 3 times negative 4. And then the second row times the second column. Negative 1 times 9 plus 3 times 1. So this is the kind of work you have to show me on the quiz tomorrow for a 2x2. I'll go ahead and tell you, I think there's only one that you have to do this with. The rest you can do in the calculator, and that's fine. But we do need to actually simplify this. So for the first one, we get 28 plus 8. And then negative 4 plus negative 12. 63 plus negative 2. And negative 9 plus 3. And truthfully, with the bigger ones, it's not harder. It's still just multiplying and adding. But you can imagine if it was a 3x3, it would take a lot longer than what we just did. Uh-huh. I see what you're saying. Truthfully, I think that's just what they decided. Later on in the unit, we'll see how we can actually solve systems of equations with these. And the only way it will work to change this, like 3x minus 4y equals 5 into something like this is if we multiply the way we're talking about. So it may just be they decided to make matrices work that way. I'm not really sure, to tell you the truth. I am sure this is the way they do it, but I understand what you're asking. Okay, now we did one by hand, so let's just focus on ones in the calculator. So everyone, get out your calculator. Everyone. Come on, computer, you can do it. Ooh. Okay, well, while we're waiting on that slide to come up, the first thing you want to do is look at the dimensions for each one. Why not? You're right. So let's just write the dimensions just so we can see why this wouldn't work out. How many rows does this first one have? Yeah, 2 rows by 3 columns. Because 2 rows, 3 columns. And this has, nope, 4 rows by 1 column. So since these two numbers are not the same, that tells us we can't do that. So you can write undefined or you can write impossible. I don't really care which one. So in a shocking turn of events, I think this next one will work. But let's do its dimensions. What's that? 4 by 2, that's right. 4 rows by 2 columns on this one. And obviously this is a 2 by 2. So since these two are the same, it does work. So in your calculator, where you need to go, If you look right here, if you look right above here, it says matrix. So if you hit second matrix, okay, come on calculator, you can do it. I missed the second somehow. Alright, hit second matrix. The first thing comes up is names. Now you cannot change what this matrix is in this spot. You have to move over to the right to where it says edit. That's where you can edit the contents inside. So hit enter, and the first thing you'll have to do is actually put the dimensions in. So this is another reason it's important to know how to name a matrix. So you have to say type 4, hit enter, type 2, hit enter, so it gives you a 4 by 2 matrix. Then you just type in all the numbers just as you see them on the problem. And it's worth, after you plug it in, always double checking to make sure you did this correctly, because if you get the wrong numbers in here, it's going to mess up your answer big time. So then we'll hit second matrix again, go all the way over to the right to the other edit, or to edit again, and this time we'll go down to B because we need to plug in a second matrix. This one's a 2 by 2, so enter 2, enter 2, enter, and then plug in the numbers in the example. Okay, one important point. Once you plug this in, you actually need to hit quit. So hit second, quit. To multiply these, we'll hit second matrix again, and this time we do use where it says names, because this is where we can actually just use the matrix. So it's already highlighting A, so I'll just hit enter, times, second matrix, go down to B, and hit enter. And there's our answer. So, just so you know, the multiplying is not required. You don't have to put that times in between. You can just do second matrix, enter for A, second matrix, enter for B, and it'll multiply them. So it doesn't matter if you do or do not put the times in there. You'll get the same answer. Yep, that's all you got to do. Once you get the numbers plugged in the second one, you hit second quit, and then go and type second matrix A times B. So that is matrix multiplication for you.